Aloha, I'm James from OhmEye, and this is my general introduction and orientation video for the 3D printer design called Reprap, Prusa, Mendel. This isn't a construction video. My goal is to show and describe what the Prusa is and how it works from the viewpoint of somebody in the community who is new to the subject. The maker community is full of people who like to make things, and just like with any large group of people, there's a lot of different interests and methods for doing things. This video is my way of showing one of my interests and some of my methods for doing 3D printing. I want to give a big picture overview of the Reprap, Prusa, Mendel and take you through the steps of actually printing a 3D object.
So what is a 3D printer? Most printers you're already familiar with are 2D. They print on paper in 2 dimensions, horizontal and vertical, or X and Y. Think of the paper as a single page or layer as in a flip book. Every page you add makes the book thicker. Each page has an X and Y axis, and we can call the stack of layers the Z axis. Instead of printing on paper, the 3D printer prints each layer directly on top of the layer underneath it. We end up with an object that's made of several layers, each one a cross-section of the object. It's like the opposite of slicing an object into very thin slices. This is my Reprap, Prusa, Mendel. It's a low-cost, do-it-yourself 3D printer design that uses open-source hardware and software components. Most of the components can be found from local sources, and anything you can't find locally can be bought online, up to and including a complete printer kit. The Prusa is just one of many 3D printer designs and is a member of a larger family of Reprap printers. Part of the concept of Reprap designs is that they should be able to print as many of their own parts as possible, making it easier to create more printers by replicating parts using the printers themselves. Joseph Prusa evolved the design from previous models with the help from the community to use fewer parts without decreasing functionality. The Prusa is a fairly simple machine and is very basic and affordable to maintain and easy to change. I don't have any direct experience with other 3D printer designs, but there are many others available, from do-it-yourself models like the Reprap to high-end commercial prototyping models. How does the Prusa 3D printer work? There are several different ways for 3D printers to build objects. The technical term for what the Prusa does is called Fused Filament Fabrication, or FFF. What it does is melt plastic and squirt it out a small nozzle precisely where it needs to go. We call the melting and squirting process extrusion, and the gadget that does it is called the extruder. We use motors to move each axis and trace the design for each layer of the object. As we move, we extrude a thin layer of plastic until the entire pattern for the layer is complete. Then the extruder moves up and draws layer after layer until the entire object is finished. On the Prusa design, the extruder moves on the x-axis, which is left and right. The build surface, also called a print bed, is the large plate at the bottom that holds the object and moves on the y-axis, which is forward and back. When the extruder moves up layer by layer, it's moving up the z-axis. The maximum size of the object you can print is the largest size that will fit within the movement range of the x, y, and z axes. My Prusa can handle about 200 by 200 by 100 millimeter, which is roughly 8 inches by 8 inches across and 4 inches tall. What objects can we print? We can print a huge variety of objects as long as they fit within the build area of the printer, and we can orient the object in a convenient way. Look at this flat-bottom drinking glass. We could print this shape right side up very easily because all layers of the glass are supported by the layer underneath. If we turn the glass upside down, the bottom of the glass that is now at the top has nothing underneath it to print on, so we may need to add removable support layers. If we were to turn the glass on its side, it would be very difficult or maybe even impossible to print. We actually can print over areas of open space in some cases. It's called bridging, and we can also print slopes out over empty space if we're careful, but there are limits. On the other hand, we can easily print some hollow or complex objects that are difficult or impossible to do with other methods such as casting. What type of plastic do we print with? We print with 2 types of plastic, and it comes in coils of thin filament. Polylactic acid, or PLA, is a renewable biodegradable plastic that's made from starch and sugars. The other common plastic we use is ABS plastic. There's a lot of info online about both PLA and ABS, but for our use, they're good for different types of objects. PLA is harder with a lower melting temperature. It's a good choice for objects that don't need to flex very much. ABS is softer and less brittle, so it's good for objects that may need to be a little flexible without breaking or shattering. The 3mm size size has been the most common standard, although with some people 1.75 millimeter is becoming popular. I'm using 3 millimeter today. Where do the objects that we print come from? The objects we print are digital files that contain 3D models. We can create the models with a variety of 3D modeling programs. Lots of people share the models they create on websites like Thingiverse.com, where we can download a model that's ready to print. The most common file format is called STL, and almost all 3D programs can import and export STL files. The modeling programs I use are OpenSCAD and Blender. All the Prusa printable parts are available as OpenSCAD files, so I can easily change a part if I want to. Let's print something! Now let's go through an actual print for an overview so we can see the individual parts at work, and I'll talk about them as we go. Here's the print bed that will hold the object. The plastic of the first layer will be extruding right onto it, so the surface needs to be covered with something the plastic will stick to. PLA and ABS don't both stick to all the same kinds of materials, but they do both stick to heated polyimide tape, also called Kapton tape. So that's what I'm using here for this PLA print we're about to do. I'm using an old laptop computer to run host software called RepSnapper. It talks to the printer controller over a USB cable. This controller electronic system is called RAMPS, which stands for Reprap Arduino Mega Pololu Shield. You can see an Arduino Mega board underneath the RAMPS board, and it has 4 stepper motor drivers on top with their little heat sinks. Don't worry if this is all Greek to you at this point. This is just one of many choices for electronics. What's important to notice for now is that I can send the commands to the printer from the laptop. Before I can print an object, I need to have a digital model of it so I can convert it into G-code. A G-code file contains the actual commands that tell the motors and extruder exactly how and when to move. I'm going to use a model I downloaded from Thingiverse.com and convert its STL file into a G-code file. Now that I have a G-code file, I have something the printer can print. On my system I have 2 choices. I can use the RepSnapper host software to read the file and send it to the printer over USB, or I can copy the G-code file onto an SD card and pop it into the reader on my RAMPS board and just use RepSnapper for basic control functions like turning things on and off. I'm going to print directly from the SD card for this print. Okay, the G-code file is on the SD card, and I'm using RepSnapper to get a file listing and to tell it which file I want to print. Now the file is selected and ready to go, so it's time to start heating things up. I'll turn on the print bed heat and the extruder heat and let them warm up. We need to use a heated print bed because PLA plastic won't stick very well to the polyimide tape we're using if it's cold. Now the heat is ready, so it's time to home all the axes. This sets the nozzle at coordinates 0, 0, 0, so it knows where its position is for the rest of the print. Homing works by moving the axis all the way in the negative direction until it hits a switch or sensor called an end stop. To know when it's reached the end, then it sets the position as 0. I'm homing the X and Y axes first, but now that we're just seconds away from starting to print, I want the extruder all primed and ready to go to make sure it's full of hot plastic. So I run the extruder a bit manually until it's streaming out nicely. Now it's time to home the Z-axis, which sets the nozzle at the perfect height above the print bed so the plastic will stick. Now Z is moving to home, which is right above the level of the print bed. I'm ready with tweezers to pull any gobs of plastic out of the way so the nozzle doesn't get gunked up. Now that the nozzle is at the right height for the first layer, it's time to let the G-code take over, so I tell the printer to start printing. And off it goes! I have my settings configured to put an outline around most of the objects I print, so that the first thing that gets printed is the outline. This way, if the extruder doesn't get off to a perfect start, it doesn't matter, since I don't care about the outline anyway. By the time it's done printing the outline, it's extruding nice and clean, so the object itself gets off to a good start. Now we're waiting and watching for the print to finish. I have my PLA filament on this spool on top of the printer so that it feeds straight down into the extruder easily. There's a lot of creative ways out there to feed filament, but I chose a simple method. And yes, this spool was printed on this printer itself with ABS plastic. Notice how the extruder moves left and right on the X-axis, and the print bed moves forward and back on the Y-axis. Both X and Y are moved by belts, each driven by a single stepper motor. I have my Y motor on the backside, so I'm less likely to bang myself or tools into it. The X-axis motor is here on this end, and the whole X-axis moves up and down along the Z-axis. The Z-axis has two motors and no belt at all. They turn two long threaded rods called lead screws and need to lift both ends at the same time against gravity. Using two motors is more powerful and actually simpler than using only one motor with a belt. This is one of the major differences between the Prusa design and previous Reprap models. See how the X and Y axes can move quite quickly. The Z-axis only moves between layers, and then only for a short period at a time, which is the actual distance between layers. This print is using a layer thickness of 0.25 millimeter, which is about 100 layers per inch. This is a Wade's extruder. The large gear turns a hobbed bolt that pulls the filament down from the spool above and pushes it into what is called the hot end. The plate with the bearings that sits on the X-axis is called the carriage, and the extruder is mounted on top, with the hot end sticking out underneath. This is a maker gear hot end. It has a ceramic-coated nichrome wire heat core, the same type of wire that toasters use for heat. The heat core is screwed onto a brass barrel with a nozzle on the end that has a small hole in the tip. The barrel is screwed into a thermal insulator which keeps the heat from melting the extruder itself. There is a thermistor for temperature sensor taped to the side of the nozzle so the controller can keep the correct temperature. The heat core and nozzle are covered by insulation. If you watch the large gear on the extruder, you can see it turn as it pulls in filament, and you can also see it move in reverse and then forward again very quickly. This is called retraction, and it's how we stop extrusion quickly when the nozzle needs to stop extruding and move to another position before continuing. On the right side of the extruder you can see the tension block with 4 springs. This block pushes a bearing against the filament so it gets pressed firmly against the hobbed bolt's teeth. The hobbing on the bolt is a threaded groove around the diameter of the bolt that I did myself with a tap. It acts like a worm gear so that as the bolt turns, the filament is pulled past the bolt by the hobb's threads. It's a very simple and reliable method for moving the plastic through the extruder. With PLA, once the print gets going and is several layers in, I like to turn the heat off so the bottom of the object doesn't get as much of a melted consistency that makes it look different from the rest of the object. Once it's past the initial sticking stage, most PLA objects stay stuck to the bed without the heat. Also, with PLA, the heat from the bed can cause fine details to warp depending on their shape and how close they are to the bed. ABS is different and needs higher heat all the way through the print to stop parts from lifting or warping off the bed. So now the bed heat is off, and we'll skip to the middle of the print. If you only print PLA and don't use ABS, you don't even need a heated bed. PLA sticks very well to masking tape, especially Scotch Blue painter's tape. Sometimes it sticks so well it's hard to get large objects off the bed when they are done, so because I have a heated bed, I use it for PLA most of the time. I only use the blue tape now for tiny objects that need to stick really well. We'll skip now to the end of the print. When we have a 3D object model in an STL file, we use a program that virtually slices it into layers. The program I use is called SkeneForge, and it slices or skeins the model into layers. When it's done, the result is a G-code file that can be sent directly to the printer's controller. There are several G-code programs, and some host software programs have one built in, but most people in the community consider SkeneForge to be the most advanced free program available. Once I got my Prusa built and the basics working, most of the work to make a good print is taking the time to tune my SkeneForge settings to get them just right. Now that I have things set pretty well, I don't need to do very much tweaking to the settings unless I change something big or decide to experiment with something new. Great! The print is finished! My G-code has commands in it to turn off the heat and get the nozzle out of the way so it doesn't sit in its last spot and melt or ooze hot plastic on the object, and it turns off power to the motors. Now I can remove the object and clean it up if needed. If the settings are tuned really well, I usually have very few strings or glitches on the object that need cleaning up. Now that you've seen a 3D printer in action and learned a little about how one works, if you would like to learn more about them or build one yourself, please visit some of the great community resources that we have available. You can find a lot of information at www.reprap.org, and you can chat personally with many active community members in the Freenode IRC channel Reprap. Thanks for viewing my video, and I'd love to see you join the Reprap community.